use that one. And by the way, let's make sure that you have your breamfish.csv or whatever CSV file in the datasets folder. We did this last time, right? Make a new folder, and on Google Drive you have the thing uploaded. So the first few lines I hope you've already done from google.colab import drive, enter drive.mount, content drive, and if you do shift enter, it's going to ask for permission. Yeah, so it's going to ask for permission to connect to your drive, use the account, and then you have to continue. And Spider users don't have to do this. You would just put the file that you need in the same drive, same folder as your Python file. Okay, and then we're going to import the operating system library, and then we're going to change directory to the folder where we have the files. Okay, so my drive, data sets, and then we shift enter. And for Spider, I think you have to do os.list directory. I guess this works too. Yeah. Okay. Yeah. But there's another way to do this in Python, which is in Colab, which is !ls. Exclamation mark allows you to have Linux commands. It will again show that I have these files. Okay. So I'm going to load up the breamfish.csv on the Spider in the Colab, and the way I do it is I'll need the pandas library. So import pandas as PD, and then we will define the data frame as pd.read CSV of breamfish.csv. Shift enter. And we went over some basics of pandas last time. And I also uploaded a link to a pandas tutorial that seemed like it really covers some basics that you have to know. And because we're going to make use of pandas, scikit-learn, numpy, and matplotlib, these 4 libraries a lot, every time I discuss this, you should spend some time trying to read on some tutorials, or there are also lots of videos online, so you should try to learn them as well. Okay. Pandas, one of the strengths of Python is that you can extend Python by making new libraries, and the creators of the pandas library liked something in the coding language called R. And in R, their data is in the form of a data frame. Data frames, if I look df.head, oh great, so it's okay. All right, okay. So a data frame looks like you have some headers. It's just like an Excel spreadsheet. And Python originally didn't have such a thing, and he liked what's in R, so this person made the pandas library so that a lot of the things that you can do in R can now be done in Python. You have a question?
Yeah, I was just gonna ask, so when you use head, df.head,
yeah,
like you're supposed to specify how many rows you want?
Oh yeah, if you don't specify, it just gives you 5 rows.
Yeah, that's what I was gonna ask.
Yeah,
just default to 5.
Yeah, good question. Yeah, you can, yeah. It's a handy thing. Once you import it from CSV or Excel or whatever, you want to know if it's correctly loaded up. Sometimes it gets messed up because the CSV file, Excel file might have a blank space in the where the header should be, and then the header becomes just numbers, and then the first data set it becomes the header, and sometimes it's messed up. So in that case, you have to do some other data cleaning. All right. So the thing that I don't like about this this data set is, oh, by the way, we've done this last time, right? So far, this is where we stopped last time. So some of you already have this much. The thing that I don't like about this is that while height and width is fine, the weight name this column has the name of weight parenthesis G, and I don't like having to type all that all the time. So let's just simplify the column names. So how do you get the column names? You have to do df.columns. Then it tells you that the column names are species, weight parenthesis G, length parenthesis centimeters, height, and width. Okay. And just to make things easier for us to write next time, we'll just rename the columns as equal to, well, just instead of species, just put S. Instead of weight, the unfortunate thing is weight starts with W and width also starts with W. So last night when I was like trying to do a walkthrough, I realized that if I do WLHW, then things break up like later on when I just want this column only. So I'm going to, instead of putting W for this, I'll put G for grams, okay? And then L, H, and W. Okay, so now I've renamed the headers as SGLHW so that if you do df.head again, you'll see that the column names, the headers became simpler. Okay? So if I want, just give me the data of length, height, and width. If I want that, then I can do df. You need two brackets with length, height, and width. Oh, I use double quotation here and single quotes. In Python, single quotes and double quotes mean the same thing. Sometimes there's a need to have a quote inside a quote. That's when you use alternate quotes. So it doesn't matter if you use a single quote or a double quote. So if I do this and then do head, then you'll see now that it's only giving me the three columns, length, height, and width. Okay? All right, so with this, I'm going to show you two ways to do the linear regression. Oh, actually three ways, because I will also want to show you how it's done in Excel. Here's the same data set in Excel. Where did? Okay. So you probably have seen this in engineering statistical analysis, how to do it in Excel. Did you? Right? Okay, some of you didn't, but I think most of you did. So the way you do it is you need the data analysis toolkit installed, and once you have it installed, if you go to data, there's the data analysis. That menu only comes up if you have the toolkit installed, okay? And then of all the things you can do, we're going to choose regression. And we're going to choose the input range as the weight. Remember, the goal of this data set, we're trying to predict the weight from length and height and width, so that maybe we don't need to measure all the weight of the fish. We can just measure the sizes, and that should be enough for us to determine the weight, right? The input X range, would now be the length, height, and width. And then I'm going to click the labels so that the very first item is considered as labels. And if I click OK, what it does, I may have messed up something. Let's see. That's good. Oh, that's all right. So OK. Then what it does, it gives you all these things, and what it means is that the predicted value would be y hat would be this value plus 12 times the length plus 62.8 times the height plus 45.89 times width, and that gives you the best approximation of the actual weight. And seeing that the significance is like 3 times 10 to the negative 19, that's a very good approximation. Okay. All right. So my goal is to be able to produce these numbers from Python. And I showed you how to do it in Excel just so that we have some reference point to make sure that we got the right thing. Okay. So let's go back to our Python. The first thing that we're going to do, we're going to use sklearn. So we're going to do this from sklearn dot linear model import linear regression. Now Python is case sensitive, so make sure you have L and R capitalized in linear regression. And then the way you use this package, and the thing is, every package is slightly different, so you really have to go through the manual. So when I use Python for work or research, I frequently have to go Google up and read the manual to see what exactly is the way you use it. And of course, I don't, because of that, I do not mandate everyone to memorize all this for the purpose of exams, okay? All right, so what am I going to do? I'm going to, so what I'm going to do is my predictors are length, height, and width. My target is the grams, the weight. So what I'm going to do is I'm going to make the linear regression function that I imported to fit the degree, the data frame of the data will be length, height, and width. So I'm going to use data frame length, height, and width with data frame grams. Okay. So I feed this in, data frame length, height, and width, and then use that to predict the data frame, the weight. Okay. Let's shift enter. Yeah. Don't worry about it if you're having trouble following, because this is being recorded. It will be made available, right? Okay, and then let's see. So let's try a few values and see if the linear regression does a good job in predicting the weight. So see this one, if the length is 30, height is 11.5, and then weight is 4.02, then the actual weight is 242. Let's see if that number is closely approximated by the linear regression. So what you do is you're going to do linear regression dot predict. Just feed in those three numbers. What if I have 30 for the length, 11.5 for the height, and weight is 4? What is it going to give me the prediction as? Sorry. So it doesn't like it, and there's some reason for this. I'll explain this in more detail next time, but if you look at the error, it says you should do reshape of -1, 1. Okay, so I'll explain why that is so next time, but for now, we're going to make this a NumPy array to feed in, and I'm going to reshape it -1, 1. Oh, a very quick explanation is that if you do reshape -1, if you just do that, that gives you a row vector. And if you do -1, 1, you get a column vector. And let me see, reshape. Oh, no, I think it should be 1, -1. No, let's see. 3, -1. Okay. Okay, so it should be that. Oh, that's not, oh,
You didn't import
I didn't import NumPy. Okay, I can't do NumPy yet. Okay, then here's another way. What it wants is, it requires, the predict requires us to put a matrix of inputs, okay? So that's why it doesn't like what we had. Okay, so what were the values? Do you remember? 30? 30, 11.5, and 4. Okay. So another way to make it as a matrix is array of arrays, right? So that's why I'm putting double brackets here. Okay, and that should work. Okay. So that gave us 220 as the output. What was the actual value? Do you remember? 242, right? So, I mean, it underestimated, but it's close. It's good enough, right? So that's how you use this, okay? All right. Another thing that you could do is you can also read the actual values, the coefficients that the linear regression generated. So if you do LR.intercept, see, if you see this thing popping up, you can do tab completion, which means if you just click tab, you don't have to type the rest of it. It just types everything for you. It's very handy. Okay, let's do Shift Enter, and then it gives you -1046. Where did we see that? We saw that in here, right? It's the same exact value the Excel generated, so it looks like we did it correctly. Okay. Another thing will be the coefficients, LR.coef _. And these are the coefficients, 12, 62.8, 45.89. Those are the exact same values, that the exact same coefficients of length, height, and width. So we did it correctly. How many of you have had some C++ or Java? Okay, all right.
I did with Arduino, I don't know if that.
Oh, okay. Yeah, Arduino doesn't count because you haven't done object-oriented. So one thing that you're missing, that maybe I might dedicate some time in this class to do some object-oriented, is your previous programming class didn't teach you object-oriented one. Maybe you did a little bit. Did you do classes in? I don't think so. Yeah, I don't think that was a part of the curriculum. But there is this big concept of object-oriented programming, and if you know that, then you get a better sense of how to work with these packages. Because every time you import a package, what you're really doing here is you're importing classes and functions. Okay, so one of the things that Python does is that's a bit different from Java and C++ is that in Python all the variables are public. So this object-oriented programming has this security capability, which has some variables as private, some as public. In Python, everything is public. And because everything is public, they also want to distinguish just by naming conventions to say which one's private and which one's public, which ones they don't want you to touch or something. So if you have a single underscore, that's like, this is really a private value. Never change it. That's like one of the things, right? Yeah. So that's one thing. If you have double underscore, that's like you should never change that value. That would actually break the code entirely. Okay, so the single underscore is like warning, don't change this. Double underscore, never touch this one. Okay, don't try to use this variable at all. This is my private one. Okay, private variable. Right. Okay. So that's why this underscore is there. Sometimes it's a bit annoying if you're not used to Python, but it's just Pythonic way of talking about the private variables. Okay, now earlier on, last time I actually gave you another way of getting the multiple regression, right? The formula was that if your y hat was like some y-intercept, I'll just put a, and then beta 1 x1 plus beta 2 x2 plus beta 3 x3, then this matrix of betas, so beta matrix is beta 1, beta 2, beta 3, is obtained by taking this x transpose x inverse and then x transpose y, where this x was the actual, so let me just say it in our context. In our context, length, height, and width are the data values, right? So the very first value was like 30, 11.5, and then 4, right? Then you have these values, right? But then you also have to subtract. So x is not just the data itself, but you have to like not normalize it. You have to center it. Okay. You have to center it by subtracting the average length. So average length values should be subtracted. Average height values should be subtracted. Average weight value should be subtracted. So you do that, and that's the matrix that we call X. Okay. And the same thing for Y. Y, we have the grams, right? It's just a single column matrix. The very first value was 242, and then you have different weights, right? And then you have to subtract the average value of the grams. And that's what's called Y, right? And if you have those matrices ready, then you can calculate beta 1, beta 2, beta 3 by using this formula, right? And someone after class asked me what this matrix is. If you take this matrix and divide it by n, that's what's called a covariance matrix. I should have mentioned that last time as well. That one is later going to be used for principal component analysis, so you're going to see this again. Okay, so you take this and divide by n. The diagonals give you the variance of each of these values, so variance of the length values, variance of the height, variance of the weight.
Everything else is zero.
And then, no, everything else will be the covariance between the two. So you might have the covariance between L and H, covariance between H and W, and then so on and so on.
Oh, so that's like what we did at the end of last semester?
Yeah, in the linear algebra course, I explained a little bit while doing the PC. Okay. All right. Now this formula still doesn't give you what A is. This A is once you have all the betas, then A is obtained by simply replacing everything by averages. So A plus beta 1 average of x1. Remember, x1 was our length, okay? So length average, beta 2 of x2. This was the height, and then beta 3 of X3 average, which was the weight average. You plug in these values and you just solve this equation for A. That gives you the intercept, okay? So let's try that. The goal is to get the exact same result, all right? Okay, so in order to do that, we first have to define the averages, right? So let's do this. We're going to say gram average would be df of G dot mean, open parenthesis, close parenthesis. And once you have this defined, we're just going to copy this 3 more times, and then we're going to put this next one as the length average, height average, HA would be H mean, and then we're going to have W average, width average, okay? Shift enter to have all right, so this is done. Okay, now we're going to import NumPy as NP, and then I'm going to make the X as a matrix of all these length, height, and width values. So let's do this. Okay, I don't know how to get rid of this. Okay, all right. So numpy.array, and I'm going to make a list of the df values. So I'm going to put df of length, but then from here I'm going to subtract the length average. You see what I'm doing, right? Oh, subtract, not minus, subtract, right? So I'm just doing exactly what I wrote on the board. I'm subtracting the length averages from the length values, length data. df, you have the height, and I'm going to subtract height average. Okay, and then df, you have width, and I'm going to subtract width average, and make that as a list, and then now that's fed into the NumPy array. See, the thing is, if I don't put NumPy array, it just gives me Python arrays and Python lists. Like, Python lists cannot do matrix multiplication, so that's why I have to do this NumPy array thing. Okay, so I put enter. Okay, so the y would be NumPy array. Okay, let's see if you understood what I was saying. So what should we do here? What should I put? We're trying to use length, height, and width to predict the weights, right? So what do I put here?
G, right?
Yeah, df g, that's correct. Yeah, minus GA, right? Okay, and then we're going to do shift enter. However, there's like one more thing. The annoying thing is when you have NumPy arrays, you really don't know what shape it is. And often, especially when you convert from Pandas data frame to NumPy array, sometimes it would have some strange dimensions that you didn't think about. So if you do x.shape, enter, you see that it's not a matrix, it's 3 by 35 by 1. Matrices are 2-dimensional, not 3-dimensional, right? So we really want it to be 2-dimensional, so that last one shouldn't be there, okay? Another problem is that it's in the wrong configuration. See, so the naming convention is that if you have n by m matrix, n is what? Is that number of rows or columns? N by m matrix.
N is the number of rows.
Yeah, n is the number of rows and m is the number of columns. How do you know that? Well, just remember the way you multiply two matrices. It's always the row of the first matrix multiplied the column of the second matrix, right? So our convention is always the first number is the number of rows, second number is the number of columns. So if you look at what the shape of this matrix would be, and that's quite important here because if you don't have the correct shape, then the matrix multiplication gets messed up. Okay. So as you can see in this one here, what's the number of rows here? 35, because we have 35 data sets, right? What's the number of columns? 3. There are 3 columns, right? So this is 35 by 3. That's what we need. Yes?
So can you just transpose it?
That's exactly what you have to do. Yeah. So because this one doesn't give you the correct dimension, what you have to do is first we have to get rid of the last one. So what we're going to do is we're going to do x equals, we're going to redefine x as x dot reshape, shape this thing as 3 by 35, okay? And then I'm going to transpose this, okay? That will be our new x. Okay. So 3 by 35 gets rid of this last one. In the actual Python representation, what it does is it removes the extra bracket that's outside. So, that's what it does. Okay, or inside, most inside, there's a bracket somewhere, and that gets rid of it. Okay. Okay, so now let's look at x dot shape and see if it's in the correct format. 35 by 3. That's good. Okay, now let's check the y as well. Y dot shape. Oh, that's good. That's already 35 by 1. So that's a column vector. Is that okay? 35 rows and 1 column, so it's a column vector. Yes?
So originally, before we transposed it, how we had 3, 35, 1, and that one is just in the third dimension, right?
Yeah, the third dimension went away because we did a reshape 335. So that 1 went away.
Okay, so if you don't
And-
include the last.
So if you do 3 by 35, that's a 2-dimensional array.
Okay.
Yeah. If you do 3 by 35 by 1, then you end up with a 3-dimensional array. Yeah. Okay. Any other questions on this? Yes.
I'm getting that like LA or HA or WA, they're not defined for spider. I don't know if you took.
I don't know. Well, I'll have to look at your code. Sorry. Yeah.
Yeah.
Yeah. Maybe somebody next to you can help. Anyone else have a question? Yeah?
The shape of my y is 1 by 35.
Oh, I don't know what happened, but it could be because of the pandas version.
Right, okay.
Yeah, so in that case, just say y is equal to y dot t. Yeah. Or let's see, does that work? Y dot t dot shape, let's see. Yeah, so say y is equal to y dot t and look for y dot shape, see if it's, okay. It's correct?
Well,
Yeah, so thank you for letting me know. Different versions of pandas might have a different convention. Yes?
You say why the T and the shape? Because I have a
No, y dot, if you have y dot shape, if you do y dot shape, the correct one that you should be getting is 35 by 1. If you get 1 by 35, then you should redefine y as y equals y dot t. Okay? Yeah, but whatever you do, you have to make it so that it's 35 by 1. Or else the formula that I wrote on the board is not going to work.
Thank you.
Any other questions? Okay, so now let's just use this. Beta, the formula on the board says, oh, I have to do inverse. Okay, so, let's do this. There's an inverse somewhere in NumPy, but it's a bit tricky to get it. So let's just import the inverse function directly. So the way you do it is from NumPy dot linear algebra, linalg, import inv. Okay. So if you do that, then you get the inverse function, matrix inversion. Okay. All right. So with that, we're going to define beta equals to x dot transpose. How do you do matrix multiplication? Do you remember?
By column.
Column.
at.
Oh.
Yeah, that's how you multiply, do matrix multiplication. Okay, so if you do x dot t at x, that's the matrix multiplication of x transpose with x, this part. Okay. But now I have to invert it, right? So what do we do? Yeah, you apply INV to this one, and then again multiply with x dot t, multiply it with y. Okay. All right, so let's see what's in beta. Okay, do you recognize these numbers? These are the exact same numbers, right? Yeah. So the formulas that we used gave us the exact same numbers. And then we're also going to say A is going to be, well, if you solve GA minus beta 1 times LA minus beta, sorry, it's not beta 1. The index convention in Python starts from 0. So we should do beta 0. And then beta 1 times, the next one is HA minus beta 2 times WA. Okay, and then let's look at what, so let's do this, just float. Yeah. Just convert it to float. And then everything should be right. Okay, let's say. All right, that's good. Okay, so we see that the value that you get is negative 1046.6.